Okay, in this video we're going to look at something called total internal reflection, which you probably haven't done before at GCSE. Now on the screen there you can see that I've got a semicircular block and I'm shining the light in this way. Okay, the light's shining through the block. Now the reason I'm shining it in like that is so there's no refraction at all on the way into the block. Okay, because I'm always going to be shining the light ray perpendicular to the surface of the block along this edge. So there's no refraction on the way in, but obviously we will expect to see refraction on the way out. So at the moment, because I'm literally shining straight along the normal line here, there is no refraction. But if I gradually start to increase my angle of incidence on the right-hand edge, okay, you can see there that I start to get refraction happening more and more. Okay, we can see there that's what we would expect to see. The light comes in, it refracts here away from the normal line on the way out of the block. We can see a tiny bit of reflection creeping in off this surface, but nothing that we wouldn't expect. Now we can keep going with this, and keep going and keep going and keep going. Now eventually though, we're going to get to a point, look, where my ray leaving the block actually goes, it's about there, actually goes straight along the edge. You can just about see it here, and then there it's going along the edge. So if I increase my angle of incidence even more, it can't refract. The angle of refraction is almost so big that it would be taking the ray back into the block, which isn't possible. So refraction now doesn't happen. And this angle, this angle of incidence where my light ray here, my refracted rays along the edge of the block, this angle of incidence at this point here is called the critical angle. And if we then increase my angle of incidence even more to be higher than the critical angle, what we see now is no refraction. All we're getting is all of the light is being reflected off the edge of the block here. And this is called total internal reflection. Total because it's all of it, internal because the light ray is staying inside the block, and reflection because obviously it is reflection that is happening there. Okay, so we can summarize then the sort of three situations. You can see there the left-hand picture, the angle of incidence is less than the critical angle, and so we just get refraction happening on the way out of the block. The middle picture, that's when the angle of incidence is equal to the critical angle, and so then the light ray is just travelling along the surface of the block. And then finally, when the angle of incidence is greater than the critical angle, we get that total internal reflection taking place. Now, there is a formula that we need to do, that we need to come up with, so let's have a look at what we've got. Now, if we go back to Snell's law from the last video, we had n1 times sine theta 1 equals n2 times sine theta 2. Now, let's imagine that we are shining our light ray in at the critical angle. So in that case, that means theta 1 is theta c, that's critical angle. Well, at that point, we know that our refracted ray goes along the edge of the block. It kind of follows the surface of the block. So that means that theta 2 must be equal to 90 degrees. Okay, because if you think about if that's the surface of my block, if the light ray is travelling along the surface of the block like this, my angle there is 90 degrees. So if theta 1 is equal to the critical angle, theta 2 is equal to 90 degrees. So going back to our formula then, I've got n1 times sine theta c equals n2 times sine of 90 degrees. Now hopefully you know that sine of 90 degrees is just equal to 1. And so what we get is n1 times sine of theta c equals n2. Okay, and therefore sine theta c equals n2 over n1. Now that is a very good general formula, okay, for working out the critical angle. More common, I suppose, you see this a lot, is if the boundary is with air. So in other words, if, like the case we had, if it's light trying to leave a material into the air, well then n2 is equal to 1. And so that gives us that sine of the critical angle equals 1 over the refractive index of your block. Alright, so both of these formulas here are ones that are worth remembering or worth being able to use. You've got that one there and that one there. Let's see if we can work out then what the refractive index of our block is. And actually we should get pretty similar to what we got in the last video, which I think was about 1.4. But let's try it. Right, here's our situation again, our block again. Because if I increase the angle of incidence, and I'm increasing it right up until I get to the critical angle, which is about there. So it's as my ray of light, you can't quite see it on the camera, but it's just about travelling there along the surface of the block. And so that means that this light ray is now shining in at the critical angle. So I'm going to just put a couple of marks on here which will allow me to draw then the path of that ray. Okay, so I can now get rid of my ray box. I can get rid of my block. Now I'm actually going to do it a little bit neater than last time, because last time my drawing was absolutely atrocious, so I am going to use a ruler. Okay, and so this is then, that's the path of my light ray going in. Okay, there it is. And this here then is my critical angle, theta C. Right, again now it's not going to be really accurate because I'm doing it with a whiteboard pen, but this is a lot easier than last time. So that is around about, we can even be a bit more accurate this time, let's say that is about 42 degrees. Right, and typically that is what a critical angle will be around about. So theta C is 42 degrees. That means my refractive index is 1 over sine of 42 degrees. Okay, and so let's put that into the calculator and see what we get. And that gives us an answer of 1.5. So that's pretty close to what we got before. There we go, our refractive index is 1.5. Okay, quite a short video there then, but hopefully that has helped you to understand total internal reflection. What I'm going to do in the next video is look at an application of total internal reflection which you need to know about. So I will speak to you soon.